one more problem concerning related rates. So this one is a bit of a riddle. We have two people, Alex and Betty, and Alex is walking west at 2 miles an hour away from an intersection that we call I. And Betty is walking south at 3 miles an hour towards the intersection. Now, if we were looking at them from above, how is the distance between them changing when Alex is 0.3 miles from I and Betty is 0.4 miles from I? So the first thing, when we have a problem like this, the first thing we need to do is to do a picture, something that where we can see the information. Okay, so first thing, here we have that they are walking west and south. So they're basically on a grid. So we can just draw two axes. Okay. They could be two streets. And there is the intersection I here. Okay. And Alex is walking west. So Alex, we will call him A. Okay. And he's walking west at 2 miles an hour. And he's walking away from the intersection. On the other hand, Betty, here, she is walking south towards the intersection at 3 miles an hour. Okay, and then we have the distance between them that will be changing over time. Okay, so the question is, how will this be changing? Okay. All right, so remember the steps that we saw that we need when solving a problem like this. Actually, once we have the graph, the whole story doesn't really matter that much. The things that we need to do first is to choose variables. So what are the important variables here? Notice that we are told that Alex is 0.3 miles from the intersection. Okay, so we have that this distance is 0.3 miles. And Betty is 0.4 miles from the intersection. Okay, so that indicates that the variables we need again, we can call them X, Y, whatever we want, but my suggestion is something that relates to the problem so that it's easy for us and we don't mix them up, okay? So I will call A, lowercase a, the distance between Alex and the intersection. So my A is this distance here. This is A. And then B is going to be the distance between Betty and the intersection. And then we need one more variable because this is asking how is the distance between them changing. Okay, so this distance here, I will call it C, just to keep the sequence, A, B, C. I could call it W, but wouldn't make so much sense, right? So let's keep it simple. So this is the distance between A and B. And it is very important when solving a problem like this that we explain what are the variables in English. Okay, we write down carefully what is what, because otherwise the problem is impossible to follow. Okay, so first step done, find the variables. Then the second step was to find a relation between the variables. Okay, but the only thing I see here that we can work with is that the three variables are the size of a square triangle, right? So we have the Pythagorean theorem that says that a squared plus b squared equals c squared. And that is done. And then the third step is the implicit differentiation. Okay, remember, imagine you are seeing this from above, okay, and you see Alex and Betty moving. The new variables a and b and the variable c that we are seeing, they are functions of t. Okay, so we can differentiate respect to t, both sides. Okay, so this is 2a dA dt plus 2b dB dt equal to c dc dt. Well, I can simplify the 2's everywhere, okay? So we have, yeah, let's write it over here. C dc dt equals a dA dt plus b dB dt. And here it's useful to write it as clean as possible, okay? Because that way we will be able to see better what we have and what we don't. That's step number 4. See what we have. Okay, so let's look again at the information. So we are told that A is 0.3 miles, B is 0.4 miles. Okay, we have that information here. We already copied it. And we also have the rates actually. Alex is moving at 2 miles an hour and Betty is moving at 3 miles an hour. So this is going to be, Alex is going to be 2 miles an hour. He is moving west. Okay, and Betty is moving 3 miles an hour. Okay. And then on the left hand side, this CDT is what I want. And C, I have no idea. It's not given in the problem. It's not given in the information. But actually I can find it. Okay, remember we have A, we have B, and we have a relation between them. So we can find C. C squared is A squared plus B squared, that is 0.3 squared plus 0.4 squared. So C is going to be the square root. So this is 0.25. Okay, so I get 0.5 miles. And I take the positive because it's a distance. So a negative distance doesn't make sense, okay? It's the distance between them. Actually, I just realized something. Let's look back at the problem. If we go back, there is one more piece of information that I missed. Here we are given the information that Betty is working towards the intersection and Alex is walking away from the intersection, but I haven't used that information at all, okay? And that is important because since Betty is walking towards the intersection, the distance is decreasing. So we need to take the rate as negative, while Alex is walking away from the intersection, so the distance is increasing, so it's positive. Okay, so the problem is done just the same, but I need to go back to the end, the very end, and see what changes I need to make. So here, this is a negative and this is a positive. Okay, so this is positive and this is negative here. Okay, so we have, let's forget about this. So we have 0.6 minus 1.2 divided by 0.5, and that is miles an hour, and that is minus 0.6 divided by 0.5 miles an hour. Okay, and that is negative 1.2 miles an hour. So this is saying that they are getting closer to each other. Okay. If we think about the problem, that makes sense because actually Betty is walking much faster towards the intersection than Alex is walking away from it. Okay, so the tendency is to get closer.